it's Naomi and Drake. This is a video on functions. Specifically in this video we're going to be looking at the graph of a particular function and finding some information about that function from the graph. So we're given the graph, we have to find f of a number, so that's like finding the y value when given the x value. We have to do kind of the opposite of that. We're given the y value for some of these problems and we have to find the x values. And then we also have to find the domain and the range. My students had trouble with this. It's in chapter 7 of the book. 7.2.1 in the study plan is pretty similar to this one. It's like 35 and 36 in the checkpoint, the week 5 checkpoint for my students. Okay, so this particular problem, we're going to start with finding f of 1. So this is one of many problems in this set. So f of 1, I'm told that the x value is 1. So I go over to the graph and I have to find a point with an x value of 1. So I kind of go over to x equals 1 and I know that anything on this vertical line is going to have an x value of 1. So this is my 1 point right here. It's 1, 3. That's going to be my 1 point where x is 1. And so the f of 1 is going to be 3, since the y value there is 3. F of 5 works exactly the same way. I would go over and I'd find 5 on the x-axis. I'd look up and down and say, oh, well, here's the 1 point where x is 5. What's the y value that goes with x being 5? And it's going to be 4 here, since this point is 5, 4. So f of 5 would have to be 4. I could do it, I could be asked to find f of 2. F of 2 would be 4. I guess f of 4 would be 5. F of 0 would be 0. F of negative 1 would be negative 4. So any of those values, I could be given the x value and asked to find the y value. Now the domain we know is the set of all x values. So we have to look at all the points and find the x value for every single one of them. So if I go through these points, maybe from left to right, since x goes from left to right, this point is the leftmost point. The x value is negative 1. This is negative 1, negative 4. But only the x value goes in the domain. This point is 0, 0. So 0 would be in the domain because x is 0 there. 1, 3 means x is 1. So 1 has to be in my domain. Continuing over, this is 2, 4. So x is 2. So 2 has to be in my domain. This is 4, 5. X is 4, y is 5. So 4, but not 5, has to be in my domain. And then this is 5, 4. Okay, 5 has to be in my domain too because x is 5 here. So that would be my domain. It's just the x values that go with all these points. If it were continuous, it might be the set of x such that x is, or negative 1 is less than x is less than 5 or something like that. And then it would include values for everything in between there. Okay. This third type of problem, we're given a y value because we're told what f of x is, and f of x is y, right? So here we're essentially being told y is 4, what is x? So if you go here and you look for points where the y value is 4, that's a height of 4, right? So there are 2 points here, this point, 2, 4, and this point, 5, 4. So there are actually multiple x values, 2 and 5 in this case. But I could have even more, and so I'm going to write it in set notation, x equals, 2 or 5. Now I could have a bunch of points lined up. I could have 2, 5, 7, 19, all give me a y value that's the same. So with functions, an x value has one and only one y value, but a y value can have lots of x values associated with it. Now the second one, f of x is 3, so I actually only have 1 point here with a height of 3. It's 1, 3, so x would have to be 1 for y to be 3. Now the range works like the domain. It's just all the y values. So I go through my points. It's a y value of negative 4, y value of 0, y value of 3, y value of 4, y value of 5, and y value of 4 again. I don't have to list it twice. So I just list out all those points, and that's the range. I hope this helps.